Hi everyone, today we're going to be talking about binomial expansion with Pascal's triangle. Anytime we have a binomial, like any of these that are to some power, we can expand them using Pascal's triangle, and it makes it a lot easier than trying to expand them by FOILing and multiplying them all out. So we'll be going over these 4 problems today. Our first one is x plus 2 to the 5th power. So the first step in expanding with Pascal's triangle is to look at the degree of the binomial. In this case, it is 5 to the 5th power. And we're going to find the corresponding row of Pascal's triangle. So the important thing to remember about Pascal's triangle is that the first row is 0. So that's our first row. Then we have row 1, row 2, row 3, row 4, and row 5. So this will be our corresponding row. 1, 5, 10, 10, 5, 1. So these numbers are going to be the coefficients in our expansion. So let's go ahead and write down these numbers. So we have 1, and then we'll have plus 5. I'm going to put a plus in front of all of these since we'll be adding all these things together. We'll have plus 10, plus 10, plus 5, and plus 1. So the next step is to look at the first term in the binomial. And the first term in this binomial is x. So I will put down, starting with the first term, I'll put down x. And I'm going to start with the degree of the polynomial. So the degree was 5, so I'll put x to the 5th power. And I'm going to go down to each term and add an x. And each time I'm going to reduce the degree by 1. So we had x to the 5th, then we'll put x to the 4th, x to the 3rd, x squared, x to the 1st, which is also just x. And this last term, we would have x to the 0, but x to the 0, that's just equal to 1. So we don't need to put anything on that last term. Our next step will be to go the opposite way. So we'll look at the second term, which in this case is 2. And we're going to start over here on the right side. And we'll do the same thing that we just did. We're just starting on the right side and going to the left this time. So we'll have 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, which is just 2. And on this term, we could put a 2 to the 0, but just like x to the 0 is 1, 2 to the 0 is also 1. And if we multiply 1 by anything, it'll just be the same. So we don't need to put anything on that term. After this, all we need to do is simplify. We did our binomial expansion. Now we're just simplifying it. So we'll look at the first term. We have 1 times x to the 5th. We can write that as x to the 5th. Our second term, we have 5x to the 4th times 2. So I can multiply the 5 and 2 together and get 10. And then I have x to the 4th. For our third term, we have 10x to the 3rd times 2 squared. So we know 2 squared is 4. So we'll have 10 times 4, which is 40 x to the 3rd. Our fourth term, we have 10x squared times 2 to the 3rd power. 2 to the 3rd power is 8. So we have 10 times 8, which is 80 x squared. The next term, we have 5 times x times 2 to the 4th. 2 to the 4th is 16. And this 5 times this 16, that would be 80. And then we have the x left over. Plus, we have 1 times 2 to the 5th. 2 to the 5th is 32. 1 times 32 is just 32. And that is our binomial expansion. Let's go on to the next problem. So, do you remember what the first step is? We'll find the row that corresponds with the degree of this polynomial. So we have 3 here. And remembering that this first row is 0, we have 0, 1, 2, 3. So this will be the row that we're looking at. So we'll write down all of these as our coefficients. 1 plus 3 plus 3 plus 1. The second step is to take the first term, start on the left side. So we'll say 2a, and since this binomial is to the 3rd power, we'll put this to the 3rd power. And we'll just go down by 1 each time. So 2a squared and 2a, and on the last one, we don't put anything. I put these in parentheses because we are taking the whole thing to the third power. So not just a to the third power, but 2 and a to the third power. So we need to put the whole thing in parentheses. And I did that for each of those. Our next step is to look at the second term. So we have 4b, and we do the same thing. We're just starting on the right side and moving left this time. So we'll do 4b to the third power, 4b to the second power, 4b to the first power, which is just 4b, and then we won't put anything on the first term. And we have done the binomial expansion. Now we just need to simplify. So we'll look at the first term, 1 times 2a to the third power. So this is the same as 1 times 2 to the third power times a to the third power. 2 to the third power is 8. 8 times 1 is 8, so we have 8a to the third power. Look at the second term. So we have 3 times 2a squared times 4b. So this 2a squared, that's the same as 2 squared times a squared. So we really have 3 times 2 squared times a squared times 4 times b. 3 times 2 squared times 4, which is 48, a squared b. Awesome, we're on to the third term. We have 3 times 2a times 4b squared. And again, this is, since it's in parentheses, this is the same as 4 squared times b squared. So if we multiply that, 3 times 2 times 4 squared, we get 96. So we'll do 96a b squared. And onto the last term, we have 1 times 4b to the third. You know this by now. Since it's in parentheses, that's the same as 4 to the third, b to the third. And 4 to the third power is 64. So we have 64b to the third. And we have simplified our binomial expansion. And on to our third example. This one is a little bit different because it has a minus sign in it. So we'll have to make sure we're looking at that as we go along. So this one is to the fourth power. We'll find the fourth row in here. Of course, this first row is 0. So we have 0, 1, 2, 3, 4. So we'll be using this row, 1, 4, 6, 4, 1. And these are the coefficients. So we have 1 plus 4 plus 6 plus 4 plus 1. So our next step is to look at the first term, 3, and we'll put that down. So we have 3 to the fourth power, 3 to the third power, 3 squared, 3 to the first power, and we won't put anything on the last term. Then we'll look at our second term, and we have negative x. So because it's a minus sign, we do need to include that negative sign in there. So this will be minus, starting from the wrong side. So this will be minus x to the fourth, minus x to the third, minus x squared, minus x, and nothing on that first term. So we've done the actual binomial expansion part. Now we'll get into simplifying, which can often be a little bit more tricky than the binomial expansion. So we have our first term, which is 3 to the fourth times 1. So it'll just be 81. Look at our second term. So we have 4 times 3 to the third times negative x. So 3 to the third is 27 times 4 is 108. And we still have this negative x. So this is actually going to be a negative 108x. So plus 6 times 3 squared. 3 squared is 9 times 6 is 54. And now we have negative x squared. So if we have negative x squared, those negative signs are going to cancel out since we would have negative times negative, and it's the same as just x squared. Our next term, we have 4 times 3 times negative x to the third power. So 4 times 3 is 12. Negative x to the third power. If we multiply negative x times itself 3 times, 2 of those negatives are going to cancel each other out, but one of them will still remain. So that'll be negative x cubed. So this is going to be negative x cubed. And then we'll look at this last term. We have 1 times negative x to the fourth power. So negative x to the fourth power, if we had 4 of those negative x's multiplying together, they would cancel each other out, just like they did in negative x squared. So this will just be x to the fourth. And there we go. And we can go in and simplify this a little bit more and just write 81 instead of plus a negative, minus 108x plus 54x squared. And again, instead of plus a negative, we'll just put minus 12x cubed plus x to the fourth. You'll notice that with any problem that has a minus sign, it's always going to alternate in your final answer. So we have a positive number, a minus, a plus, a minus, and a plus. If it doesn't alternate like that, you know that something went wrong and you can go back and check your work. And one more final example here, x squared plus 4y to the 6th to the third power. So we'll find our corresponding row in Pascal's triangle. We have rows 0, 1, 2, 3. So this row with 1, 3, 3, 1, that will be our coefficients. So we'll do 1 plus 3 plus 3 plus 1. Look at our first term, we have x squared. So we'll put x squared to the third power, x squared to the second power, x squared to the first power, and nothing on this last term. Then we'll look at our second term, 4y to the 6th, and we'll start on the right side. We'll put 4y to the 6th to the third power, 4y to the 6th to the second power, 4y to the 6th, and nothing on the first term. So these parentheses in here are really important again, since we have multiple things that are to the second power. In this one, for example, we want the y to the 6th to be a second power and the 4 to be to the second power. So do make sure that you are putting these things into parentheses. So we've completed our binomial expansion. Now we'll get to everyone's favorite part, simplifying. So 1 times x squared to the third. When we have exponents like this, that are kind of on top of each other like that, we multiply them. So 2 times 3 is 6, so this will be x to the 6th power. Plus, we have 3 times x squared times 4y to the 6th. So I can see that I'm going to have a 3 and a 4 I need to multiply together as constants. That'll be 12. And then this x squared, 2 times 2 is 4, so it'll be x to the 4th. And then I have y to the 6th. Okay, let's look at the next term. We have 3 times x squared to the first power times 4y6 to the second power. So I see my constants here. I have this 3, and then I have this 4 that's going to be squared, so 4 squared. So I have 3 times 4 squared, which is 48. And then I have x squared, and then y to the 6th squared. 6 times 2 is 12, so it'll be 12. And our last term, we have 1 times 4y6 to the third power. This is the same as 4 to the third times y to the 6th to the third. So 4 to the third is 64. And then y to the 6th to the third. 6 times 3 is 18. So we have y to the 18th. Thank you so much for joining me today, learning about binomial expansion with Pascal's triangle. This is such a fun little trick that we get to use to make our lives a little bit easier. If you are looking for more math goodies, more math help, head over to my website at katietutorsmath.com and subscribe to my YouTube channel.